Hello everybody, welcome or welcome back. In today's video we'll be seeing Wilson's theorem in modular arithmetic chapter. So just first I'll write the basic formula and directly we'll go to the question, and then then we'll understand better how we can solve them. Okay. So this is mainly used when there is involvement of factorial. That is one way to remember. So p minus 1 factorial is congruent to minus 1 mod p, or it is another formula, p minus 1 factorial is congruent to p minus 1 mod p, where p is basically prime number. P minus 1 factorial is congruent to minus 1 mod p, or p minus 1 factorial is congruent to p minus 1 mod p. This p minus 1 factorial we can also write it as p minus 1 into p minus 2 factorial, or p minus 1 into p minus 2 into p minus 3 factorial. So when we solve questions, I'm going to tell about that. Now let's solve the first question under this topic. The first question says, what is the remainder when 12 factorial is divided by 13? So what did I say? The formula is p, any one of them you can use. I'll use the second one for now. P minus 1 factorial is congruent to p minus 1 mod 13, mod p. Okay, mod p I'll write. Okay, mod p. So p here is what? P prime number 13, correct? So 13 minus 1 factorial is congruent to 13 minus 1 mod 13. So 12 factorial is congruent to 12 mod 13. So what is the question? 12 factorial divided by 13. 12 factorial divided by 13. What is the remainder? Remainder is 12. That's it. First question was simple, isn't it? Okay, let's move to the next question. Find the remainder when 146 factorial is divided by 149. Again, you can use any of the formulas, this one or this one, anything. I'm going to try first the second formula. So p minus 1 factorial is congruent to p minus 1 mod p. P here is what? 149 prime number. So 149 minus 1 factorial is congruent to 149 minus 1 mod 149. That's going to be 148 factorial is congruent to 148 mod 149. Now what do we have to see? We want 146 factorial. Here what is a 148 factorial? So I can write it as 148 into 147 into 146 factorial is congruent to 148 mod 149. Nothing is changing in the RHS as of now. Okay. So this I'm going to write it as 148 one second, just give me a second. 146. So 148 minus 2 into 147 minus 1 into 146 factorial is congruent to 148 mod 149. So this directly cancels minus 2. Just remember how to do. Okay, don't complicate, don't write on right side, left side. No. Here 140, 146 actually you can sorry, here also it is going to be we want 146, so 140 mod 17 with with respect to 149 is supposed to write. It's supposed to 149 is supposed to number respect to 148. So 149 minus 1, 149 minus 2, 141 147 into 146 factorial is congruent to 148 mod 149. So minus 1 into minus 2, minus 1 into minus 2 into 146 factorial is congruent to 148 mod 149. So it's going to be 2 146 factorial is congruent to 148 mod 149. Now 148 divided by 2, if I have to do 148 by 2, I will get 74. 2 into 146 factorial is congruent to 74. Sorry, 2 here will get cancelled. So 2 is congruent to 74 mod 149. So 74 is the remainder. That's it. So what did we do? Till here I hope everyone has understood basic formula substitution. Then we want 146 factorial. Not here we have 148. So using this 149, 148 is basically 148 into 147 into 146 factorial. This also we should know. This I told you orally, right? 148 can be written as 149 minus 1, 147 can be written as 149 minus 2, and 146 factorial. So this 149 I'm going to remove it. I'm going to keep just minus 1 minus 146 factorial is congruent to 148 mod 149. Then I get 2 into 146 factorial is congruent to 148 mod 149. 2 if I multiply by 74 I get 148, so I'm going to write that, and then that is going to be the remainder. That's it. Okay, I hope this is clear. Next question, the remainder when 14 factorial is divided by 17. So what is the formula? P minus 1 factorial is congruent to P minus 1 mod P. So P is what here? 17. So 17 minus 1 factorial is congruent to 17 minus 1 mod P. So 16 factorial is congruent to 16 mod P. 16 factorial, we want 14 factorial. So 16 into 15 into 14 factorial is congruent to 16 mod 16. Okay, 16. This in terms of, divided by 17. With terms of 17, right? 17 minus 1 into 17 minus 2 into 14 factorial is congruent to 16 mod 17. So minus 1 into minus 2 into 14 factorial is congruent to 16 mod 17. Don't think too much, just follow the procedure. So 2 into 14 factorial is congruent to 16 mod 17. So 14 factorial is congruent to 8 mod 17. So when 14 factorial is divided by 17, 8 is the remainder. That's it. Wasn't it simple? Okay, now let's go. This next is the last question of Wilson's, which we are mainly focusing on for exam purpose. And this question we will not be using. We are not using Wilson. This question which I am doing, it was going to be very lengthy, so that's why we want to solve without using Wilson. But I've just taken it in this video. Okay. So the question is, find the remainder when 1 factorial plus 2 factorial plus 3 factorial up to 202 factorial is divided by 21. So first we should, this much we should know, that 1 is congruent to 1 mod 21. 1 is congruent to 1 mod 21. Sorry, 1 factorial. Factorial I am writing, but we technically not using Wilson. Okay, 1 factorial is congruent to 1 mod 21. 2 factorial is congruent to 2 mod 21. 3 factorial is congruent to 6 mod 21, not 3 mod 21. 3 into 2 is what? 6. 4 factorial is congruent to 4 into 3 into 2 into 1. What is it? 24 mod 21. But it has to be less than this. So what are we going to do? 21, 24, 21. 1s are 21. 3. So 4 factorial is congruent to 3 mod 21. Next, 5 factorial is congruent to 5 into 4 into 3 into 2. That is going to be 120 mod 21. So 21 by 120. 120 by 21. That's basically 21 into 5, which is 105, which is basically 15 will get. So 5 factorial is congruent to 105 mod 21. 6 factorial is congruent to 6 into 5 into 4 into 3 into 2 into 1. Don't worry, we will not do till 202. I will tell you when to stop. Just give me just few minutes. Now 720 by 21 if I do, I will get 34. So 21 by 7, what is it? 720. So that will be 34 times. So 21 into 34 is 714, and I will get 6 as the remainder. So 6 factorial is congruent to 6 mod 21. Now when we take 7 factorial, right, that's going to be 7 into 6 into 5 into 4 into 3 into 2 into 1. That's going to be 7 into 3 into 6 into 5 into whatever, 4 into 2 into 1. 7 to 3 is what? 21. Now 21, if I'm going to divide, I'm obviously going to get remainder 0. So if remainder is 0, so we're not going to consider it. If 7 has, then obviously 8 factorial also will have 9, 10, all that rest, everything else will have. So we're going to stop it till here. And this much only we're going to add. So 1 factorial plus 2 factorial plus 3 factorial plus 4 factorial plus 5 factorial plus 6 factorial is congruent to, what is it going to be? This you have to count. So 1 plus 2 plus 6 plus 3 plus 105 plus 6. 123 are we getting? Have we made some mistake? Oh yes, we have made some mistake. That is, this is 15, not 105. Sorry. Yeah, whatever. 1 plus 2 plus 6 plus 3 plus 15 plus 6. Yes, is congruent to 33 mod 21. But again, 33 is greater than 21. So 33, like this we can write 21, 1, 2, 12. So that time we get congruent to 12 mod 21. So 12 is the remainder. That's it. So this one question where this is done, we are not using Wilson's theorem. We are doing it by this method. Why am I not taking 7? That also I explained, because 7 to 3 is 21. So remainder will become 0 when I am going to divide by 21. That's because the always are going to be multiples of 21, right? So this was it. So in the next one we'll see Fermat's theorem, which is a special case of Euler's basically. So until then, take care, see you, bye bye, and see you in the next one.